So today we are going to start a new chapter that is called buoyancy. This is buoyancy and this is metacentric height. So first of all, you should understand what do you mean by this buoyancy. So this is suppose a water body or this is water. Okay. Suppose you are going to submerge near one object. Suppose you are going to submerge a object into this water. So what will happen? This water is give rise to a reaction force to this body. Okay. That reaction force which is all given by this fluid onto this body known as upthrust, or that is called as buoyancy force. So this force which is actually exerted by this water onto this object, that is called buoyancy. So how to measure this buoyancy? Okay, how to measure this magnitude of this buoyancy force and how to locate that one? So a very interesting experiment has been conducted to find out this magnitude of this buoyancy force. And suppose this is a container from water, there some water is contained, there's some volume of water is there written in a container, and suppose you have just put one object into this water. So when this object is fully submerged, what will happen? The water will rise. Okay, the water will rise definitely, and some water will rise, and so suppose you make a hole here. So whatever the water will rise, that will be spill out, and that will be collected in this container. The water which is spill out after the submergence of this body, and you just collected the water, and you just measure the weight of that water. You just measure the weight of that displaced water due to the submergence of this object. That weight of the displaced water, okay, weight of the displaced water magnitude is nothing but is called as buoyancy force. Okay, so this buoyancy force will be weight of the equal to the weight of the displaced water. So weight of the displaced water will be mass of the displaced water into G. So what is the mass of the displaced water? The density of the water, density of the fluid, okay, into how much the volume will displaced. Okay, how much volume will be displaced? Okay, this is the volume displaced into G. So this volume displaced will be equal to how much volume is submerged. How much volume is submerged by this object, that is called volume displaced. That amount of fluid will be displaced by this object, that is represented by volume of submergence. This is the volume of submerged, indicated by P. So this force of buoyancy magnitude will be density of the fluid into this how much volume will be submerged into G. This is called force of buoyancy, and this is given by Archimedes. This is called Archimedes principle. Okay, so if you draw the free body diagram, suppose this is the center of gravity, this is CG, and suppose this point where this buoyancy force will act, that is called center of buoyancy. Through this CG, what will happen? Thus, weight of this body will act. Okay, so the center of buoyancy will be the centroid of so this is centroid of the volume of water displaced. Okay, so this is we have to find out the centroid of this submergence. How much submerged volume or how much volume will be displaced. That centroid will be equal to center of buoyancy. So through the center of buoyancy, this buoyancy force will be, and through the center of gravity, the weight will. This is the free body diagram of this one. So now already we found out the magnitude of this one. So we have to find out. Suppose this is my this water is there, and suppose this is my object has been submerged. Okay, and suppose this is my height is h, capital H. This is height of the body, and this is the how much actually has been submerged. This part is submerged in this water. So you have to estimate how much actually submerged in this water. So you draw the free body diagram. So this is the centroid of the submerged. So through this, your buoyancy force will be exerted by the water to the body, and this is the centroid of this is center of buoyancy and the center of gravity. So through the center of gravity, what will happen? The weight of the body will act. So at equilibrium, I am writing here. So at equilibrium, so net force in y direction will be 0. Suppose this is my x, positive x, and this is my positive y direction. So this weight is acting in downward direction. So this will be a buoyancy force. This is F of buoyancy minus W will be equal to 0. So I can write this is F of buoyancy will be equal to W. Okay. So now this buoyancy force magnitude already I have estimated. Okay, this buoyancy force magnitude already I have calculated. This is density of the fluid into this is how much volume has been submerged volume. This is G, and this is weight of the body. This is weight of the body. So this is definitely this mass of the body into G. Again, I can write down this one. This is density of this fluid, and suppose the cross-sectional area. So if you see the top view, this is the cross-sectional part. So this is cross-sectional area is A. Suppose. So I can write down the volume of submerged as cross-sectional area into small h into G, and this mass of body I can write down density of the body into volume of the body. So volume of the I can write down this cross-sectional area into capital H. So will into G. So this G gone, this A gone, this is A G. So if we divided both one in density of the water, this one density of the water. So this is specific gravity of the fluid into small h will be equal to specific gravity of the body into capital H. Okay, capital H. So if you want to find out what is the submerged, so small h will be equal to how much? A specific gravity of this body divided by specific gravity of the fluid into how much h. This is the formula you have to use to calculate the how much actually this has been submerged. Okay, this is the very important formula you have to remember. This is you have to use in to calculate this everything in your problem. Now you have to solve one numericals or based on this one. So suppose this is water, and suppose this is a balloon. Okay, this is a balloon. Okay, this is a balloon, and to this balloon one metal is attached. So this is a metal. This is one balloon. Okay, this is a balloon, and this is here a metal attached by a string. This is a string. Okay, this is a string. So suppose, and this is water. This is water. This is water. Water is there. So this is water. So we have to find out. What is the tension exerted in this string. What is the tension exerted in this string? So if you draw the free body diagram of this metal. So this is the metal. Okay. So the buoyancy force is exerted by this water onto this metal. This is buoyancy force, and this is the suppose it is completely submerged. Okay, the center of buoyancy will be equal to center of gravity, and this is the weight of the metal will act. Okay, and the tension will act in upward direction. The tension in the string. So if you write down the net force in y will be equal to 0. So this is T plus Fb will be equal to this method. Okay, so this T plus FB is already this density of the fluid, and this is how much volume has been submerged, and this is G, and this is weight of the metal, density of the metal into G into this volume of the metal. So this tension will be equal to density of the metal is given 2000 into this is suppose this is approximately 10, and this volume of metal is given 0.1 meter cube. Okay, this is minus this is density of the fluid water is there, so this is 1000, so this is 10, and this is volume of submerged will be equal to how much volume of submerged, that is completely submerged, so I can this is equal to volume of metal only, so this is 0. So if you do this, the tension force in the string, you will have to find out this one is a 1000 Newton. So I am giving one assignment to you, so you just find out what should be the volume of the submergence of this balloon. Okay, of this balloon, if the density of this balloon is given as 100 kg per meter cube, and this volume of this one balloon is given as 1 meter cube. So you find out what how much has been submerged by this and the weighted volume of the balloon, the weighted volume of this balloon. Okay, this is it. Thank you. Next class we'll discuss better. Stay at home and